All right. Hello and welcome. We're going to pick up today where we left off on Atsukovsky's Etherdynamics. Oops. All right. There we go. Microphone. Okay. Okay. And then, all right. So this is chapter 3.22. Model qualitative representations of structures and processes. Let me just snag that real quick. Come on, man. Whatever. Fix it later. Okay. All right. Identification of the internal mechanism of any phenomenon is possible if the principle of causality is recognized for the links and interactions of material entities involved in them, of the material entities involved in them. Since physical phenomenon are the consequence of internal processes, often insensible at the achieved level of physical development, the recognition of the fact of causality is of fundamental importance because in advance of all stages of cognition asserts the existence of the internal mechanism of the phenomenon and the fundamental possibility of its disclosure. It is reasonable in this connection to recall the following statement of Engels. But, but where on the surface there is a play of chance, this chance itself turns out to be subject to internal hidden laws. It is all a matter of discovering these laws. At present, however, the opposite point of view is much more widespread, believing the structure of the world to be an indeterministic, or to be indeterministic, and the imposing fundamental limitation on the possibility of the study of cognition. Sorry about that. Indeterministic. All right. The rejection of these ideas about the existence of nature, about the rejection of ideas about the existence in nature of the ether, the world medium, which is the building material of matter, led physics to the rejection of the intra-atomic medium. Quantum mechanics, which appeared in the 1920s, appeared in the 20s after the formation of the theory of relativity, began to operate with mathematical abstraction, relying, however, on the planetary model of Rutherford put forward in 1911. Quite clear, the processing many the quite clear, but processing many shortcomings. So I think this was the guy that came up with like the little tiny quantum orbits or whatever. The Rutherford guy. Pretty sure that's who that is. Let's see. All right, these shortcomings led to numerous paradoxes, which were treated by not improving the obviously unsatisfactory model, but by introducing postulates and principles, free statements like axioms, the justifications of which was at some corollaries of them were confirmed. However, the limitless spread of the postulates and principles led to new paradoxes, which were treated in the same way. The mechanism of the phenomenon itself was not considered. The position, uh, the position expressed at the beginning of the 20th century in the address of physics by uh, Vladimir Lenin was confirmed. Matter has disappeared and only the equation remains, i.e., exactly physical ideas about the structure of the world were thrown out, but thereby the road to a dead end was paved. The well-known Heisenberg uncertainty principle, in quotes, inter interdeterminacy, the interdeterminacy principle, according to Bohr's expression, led physicists to the conclusion that investigations carried out at the quantum level, more precisely at the level of matter division of into elementary particles of matter, the exact causal laws of the detailed behavior of such individual systems cannot be found in principle, and thus it is necessary to refuse causality as such in the atomic field. This actually put a barrier on the possibility of cognition of matter and regularities of the real world. Therefore, some leading physicists do not agree with the principle of oh man, this word's killing me. Interdeterminism, the principle of interdeterminism. They consider randomness as a consequence of not taking into account objective existing factors. Thus, Baum in citation 12 points out that in experiments there are always irrelevant, unaccounted for factors that distort the results, which manifest itself as randomness. However, it should be noted that Baum pointed out only one subjective side of the manifestation of randomness. No less important is the second objective side related to the fact that for the effect to manifest itself at the macro process level, it is necessary to accumulate sufficient changes at the micro process level. This circumstance is connected with all things at the quantum and discrete processes, with all kinds of nonlinearities, zones of intensities, and feedbacks of internal regulators of the phenomenon, etc. As an example, we can cite an ordinary dry friction. An object lying on some hard surface will not move from a place until forces applied to it reaches a certain value, after which it is moved with a jerk because with the value of friction will fall off as soon as the object moves from its place. But similar process can take place at the micro, but a similar process can take place in the microcosm. A good example is the formation of vortices in fluid flow at a certain ratio between velocity, body size, and viscosity of the medium, called Reynolds number. At small values of number, no vortices are formed, but if the velocity increases and the Reynolds number increases, from a certain point turbulence, and then stable vortices begin to appear. Oh, that's really interesting. So Reynolds number, I never heard of that. Shout out to your boy Reynolds. So, cop that Reynolds number. It should be noted that the occurrence of all processes at the level of the microcosm does not objectively depend on the fact of observability, although many physicists assert a certain solipsism. A phenomenon exists insofar as we observe it, and therefore the distortions of the microcosm does not depend on the fact of observability. The result of measuring instruments are fundamental and do not allow us to draw unambiguous conclusions about the nature of the phenomenon. In fact, the measuring technique, due to its imperfections, can, of course, distort the result of the experiment and, if appropriate. Yo, what up, Brandon? Shout out to your boy. What up? So let's see here. Yeah, this is awesome. The historicity of it, I really enjoyed. Even though it was kind of boring to read, but going back, there's a lot of useful information that will be applied later. I'm working on a little presentation to put together for Toby's event on Monday, I think it is, on the Ether Cosmology channel. I'm gonna do a little presentation on the scientificness. Like, is the ether scientific? What is the difference between a framework and all that, and just kind of like lay it out, because a lot of it was actually covered in the beginning of this book, and I feel like a lot of it actually applies to the circumstance we're in now, trying to interpretate all these various ether interpretations from the past and all that sort of stuff. So this book has been a really nice guide forward into uncharted territory. Lots of good documentation here and explanations of the mechanisms that we're not really told about, right? Because we're told, like, oh yeah, these people used to believe in the ether, but like now, Einstein disproved it. But it's like, why did they believe in it? Well, it's like there's a very there's a very degree of specificity involved as to why they believed it. They believed that there had to be a mechanism to, um, for all sorts of actions. There was no action at a distance. Everything was carried through a wave or pressure mediation. Like this idea of a vacuum is just like is craziness. Like the way that it's taught to us now, it's all like the normal. But back then, that's why everybody was like, "What are you guys talking about? It's a vacuum." But anyway, I'll continue reading here. Yo, what up, Thrash? And no longer on the ball. What's up? What's up? All right. Let's see here. So I think I was right here. From the stated position follows the fundamental possibility of studying the internal mechanisms of the phenomenon at any level of organization of matter. Recognizing the fact of causality allows us to reveal the mechanism of the phenomenon and raise questions of the elementary interactions within the phenomenon. These elementary interactions can occur between interacting elements only through direct contact in a common point of space, whether it is a direct collision of particles or interactions of particles with a field. The principle, the principle of action at a distance, which implies the interaction of two elements through empty space, fundamentally cannot reveal the mechanism of the phenomenon precisely because it means the existence of empty space between the interacting elements. This principle was condemned by physicists back in the 19th century, and there is no need to return to it, although such attempts are still ongoing. Yeah, it's a real shame. Uh, let's see. That nobody, I think this dude's still alive too. That's funny. It's as if they like stopped doing it or whatever, or like it was dying down. Like no, they completed it and kept going in perpetuity. So let's see here. I like that this little part here. Each elementary interaction is a consequence of another elementary interaction, and in turn is the case of a subsequent interaction for other elements. Thus, there is a continuous chain of cause and effect events. So, a constant back and forth pressure mediation, return. What's the word I'm looking for? Equilibrium, seeking equilibrium. You know, all that good stuff. All right. Recognition of the continuity of causal chains and events it implies, generally speaking, a single internal mechanism for all internal phenomenon and interactions. At least it does not exclude such a mechanism. It is interesting to note that history shows how, despite the increasing number of diverse phenomenon and the increasingly or seemingly increasingly possibility of multiplication of the variants of mechanisms of the phenomenon. In fact, in the process of development of natural science, there was a process of reducing the number of these variants. Let's see. In 1922, Fourier concluded in citation 13 that, however comprehensive mechanical theories may be, they are in no way applicable to the thermal effects. Heat belongs to a special category of phenomenon that cannot be explained by the laws of motion and equilibrium. And already in 1868, i.e., 46 years after the statement of Fourier, Boltzmann showed in citation 14 and citation 15 that thermal motion is a kind of mechanical motion. This process is the process of reducing the number of varieties of interactions continue. That's like that's very that's almost heat boils water esque. They're like, it can't be. This is it belongs to a special thing. It can't be a law of motion. And then your boy just shows up like, yeah, it's definitely a law of motion, homie. It's funny. Save that real quick. It's very applicable to a recent argument. This process of reducing the number of varieties of interactions continues. At present, it is reduced to four: nuclear, strong, nuclear weak, electromagnetic, and gravitation. However, the recognition of the closed however the recognition of the closed causal chain of all events leads to the conclusion that there must be a single process at the heart of these four interactions. For or from the fact that there is nothing in the world but moving matter, it follows it with necessity that this single process must be the movement of material masses in space, and consequently, all the so-called fundamental interactions must be reduced to mechanical movement of material masses in space. So, a pressure mediation within the medium. The principal possibility of uncovering the internal mechanism of the phenomenon can be realized in various ways. One of them is the method of proposing random hypotheses and consequences of which are tested and compared with real events. These hypotheses can be of abstract mathematical character or they can be of qualitative nature. A positive example is the Schrödinger equation, which is composed rather abstractly but gave a range of solutions suitable for considering the phenomenon of the microcosm quite satisfactorily, considering or coinciding with practical observations. Another example is the same theory of relativity, which allowed not only to describe some known phenomenon, but also to predict some new ones. But post-dick, really, though. You know what I'm saying? So, yo, what up, flat plane? Let's see. However, despite the internal attractiveness of this method, in many cases it leads away from reality because it does not reveal the inner essence of the phenomenon. Indeed, an arbitrary hypothesis put in the basis of the study of the phenomenon will yield an equally arbitrary system of corollaries, which just as casually may coincide with some of the phenomenon, giving the impression of plausibility. There is no certainty, however, that those corollaries will coincide with other facts of reality not yet discovered, and the discovery of new facts will be hindered to the extent that the hypothesis that has gained acceptance proves unsuccessful in predicting them. Greetings, truthlings. Nice. Since each private phenomenon can be explained in many ways, not one way, a group of private phenomenon can satisfactorily be accommodated in any number of hypotheses and theories generalizing them. Consequently, the way of comparing the consequences arising from the hypothesis is quite insufficient. Consideration of these essential aspects of the mechanism of the phenomenon can arise only from the notion of their generality, which requires simultaneous consideration of all known phenomenon and identification of their common features. However, even in this case, any number of these theories is possible, including mutually excluding each other. A good example here is Einstein's special theory of relativity, which categorically denies the presence of the ether in nature, but uses the mathematical basis of Lorentz transformations, which is derived from his theory of an immovable ether. Yo, yeah, this is the FE Insomniac channel, dog. There's a good chance I'll be up till I don't know 6 o'clock in the morning. Who knows? Uh, that's exactly what it is. All right, so let's see. So Lorentz's mathematic structure and Lorentz covariance and all that, and the Lorentz transformations, obviously. Um, Einstein's special theory just takes the entire framework and applies that, but just says that just says, well, there's no mechanism that does it. That's just the coordinate system that contracts. It's just space and time are interconnected, and when you're moving fast, you're experiencing length contraction of time and space, or time dilation and length contraction, and it's so like that's the point he was making there. When you get carried away with the math, and then you can just apply it to however you want to fit it, abstractly, which is exactly what they did. Let's see, which should be a dead giveaway because like they're so hardcore into like no ether. Einstein disproved it, all this stuff, and it's like, guys, it's the same theory. It's just a different mechanism. It's the same math, guys. Consequent, and there's second order corrections too. You know what I'm saying? So that's the other thing with the merging of the space and the times. Consequently, in order to construct the generalizing theory, the provisions of dialectic materialism must be taken into account in addition to the phenomenon, which must be treated experimentally verified facts reflecting the most general aspects of the real world. In addition, the theory should outline its boundaries and the possibilities of subsequent clarification. The contradictions of the theory to the real fact should be used to clarify the theory, if necessary, its change, not disregarding the fact, as did special relativity theory with experiments with the ether wind. So yeah, as relativity theory was consistently getting body bagged, they used the general theory to co-opt all the other experiments and just say that rotation energy is equivalent to gravitation, which is equivalent to generating, time dilation and length contraction. They just swooped it up. It's really cool that they can do that. Like you gotta give them credit. They just swooped it up mathematically. So let's see. All right. Finally, the theory should proceed from qualitative representations supported by quantitative functional descriptions. Thus, qualitative representations should allow to find borders and admissible simplifications of functional qualitative descriptions at the decisions of concrete problems. So I think he's saying it should like reduce back. You should be able to explain it easily without overcomplicating it on any scale, I guess. It should be remembered that every object of the phenomenon has an innumerable sides of qualities and therefore can only be fully described by an infinite number of equations with an infinite number of terms. Thus, any real mathematical description of a subject or phenomenon is partially an approximate, covering only some aspects of the subject or the studied phenomenon, at that even not always essential the for the goal of the research. Hence, it follows that ideas about any subject or phenomenon, i.e., their models, can and should be continuously reified, respectively. Mathematical dependencies describing these models can and re should be refined, and the number of approximations and refinements is infinite. The method proposed below, proceeding from the objective materiality of phenomenon, from their causality at all levels of the organization of matter, from the notion of the unity of natural phenomenon and the need for consistent approximations of the model's descriptions to reality, does not does not represent something, is particularly new. It is the usual method of materialistic theory of cognition. It is this method that can allow us to construct a generalizing theory of matter interactions and physical phenomenon. All right. 3.2.3 Ways to uncover the internal mechanisms of phenomenon. When determining ways to uncover the internal mechanisms of phenomenon, there arises a certain fundamental difficulty associated with the fact that the number of properties of each phenomenon and each of its elements is, in principle, infinitely large. Therefore, it becomes especially important to select from the totality of properties those that are essential for the task at hand. At the same time, it is necessary to determine the attitude to discard properties, since their failure to take them into account leads to epistemological simplifications of forms of matter and phenomenon. The issue of methodology of simplification of research subjects has been repeatedly considered in the literature. The criterion of simplicity has been often used by researchers as one of the main arguments in choosing one theory or another. Therefore, it is reasonable to dwell on this aspect in more detail. In some ways, for example, in citation 16, it is proposed to use inductive simplicity as a criterion of truth when choosing one or another theoretical system, i.e., to prefer that system of representation whose premises remain invariant with respect to a wider group of transformations. It should be objected, however, that that since the groups of transformations themselves reflected the level of knowledge attained and are necessarily one-sided in this sense, such an approach is subjective. The preference for a simpler path may lead researchers to stray from the original goal of truth seeking. For example, it is much easier to abstract from the internal mechanism of the phenomenon to give the mathematical description an independent meaning, which will lead in the end to the fact that the primary ideas will be those that are most convenient in mathematical terms. Unfortunately, this is exactly what happens quite often. An example of this is the whole quantum mechanics, which completely ignored the existence of the interatomic mechanism and replacing it with probabilistic concepts. Oh yeah, let me change that. So it was 3.2.3, I think. Yeah, 2.3. The simplicity, or the so-called simplicity principle, is often found to ignore all real physical picture of the world. What distant consequences such an approach can lead is shown by the example of Mach's statement. Rejecting the concept of quantity, Mach recognizes the notion of mass as a mathematical quantity satisfying some equations of theoretical physics, which is very convenient for science, i.e., mass appears not as an objective reality, but as some convenient coefficient in the equations for the researcher, i.e., mass here is not an objective reality, but a certain convenient for the researcher's coefficient in the equations. All right. Einstein writes, concepts and relations, especially the existence of real objects in general, the existence of the quote-unquote real world, is justified only insofar as it is related to the sense of perceptions between which it forms a mental connection. One of Kant's great merits is that he showed the meaninglessness of asserting the reality of the external world without this cognizability. The aim of science is, on the one hand, to cognize as fully as possible the relation between the perceptions in their totality, and on the other hand, to achieve this aim by applying the minimum and primary concepts of relation. Yeah, dude, that's classic Einstein, bro. The guy who rejected the ether in the special theory and then brought it back in the general theory said, quote unquote, in two different books, the general theory without the idea of the ether is unthinkable. Like, okay. Like, what are you talking about, guy? Did you even write your own theories? But you know, Einstein, he was just such a crazy goofster. So let's see here. Where were we at? Asserting cognizant abilities, driving the minimal logical elements. The aim of science is, on the one hand, to cognize as fully as possible the relation between the sense and perception and the totality, and on the other hand, to achieve this aim by applying the minimum primary concepts of relation, achieving as far as possible logic unity in the picture of the world, i.e., striving for the minimum of logical elements. It should be noted that for Einstein, the criterion of simplicity was a direct guide to action. As mentioned above in citation 19, Einstein noted that in order to resolve the contradictions in the conclusions of the results of the experiments of Fizeau and Michelson, and these are the first interferometry experiments. I think Fizeau did like a similar thing with as Airy's failure. Not he wasn't quite on the interferometry grind, but he did like an Airy's failure type thing. Um, so anyway, he sees two possibilities. One, the ether is completely motionless, or two, the ether is carried away by moving matter, but it moves at speed different from that motion of the matter. He further writes, the development of the second hypothesis requires the introduction of the assumption concerning the relation between the ether and moving matter. The first possibility is very simple, and for its development on the basis of Maxwell's equations does not acquire any additional hypothesis that could complicate the foundations of the theory. This position led Einstein to reject the ether. Wait a minute. Why is it concerning the relation between the moving matter? Oh, okay, yeah. So it was the preferred reference frame showing that with the moving conductor over a magnet and the magnet over a stationary conductor, um, saying that all reference frames are equally valid. It doesn't matter, and so that he was removing the idea that there was an ether, which would be the absolute reference frame. So he was saying that it was all relative. Okay, all right. Let's see. Now, we can only wonder what conclusions would have come to Einstein if he had not been seduced by the simplicity of the first position and would have investigated the second, more complex. In any case, it is clear that no rejection of the ether here in the principle could not be discussed, but also the special theory of relativity would not have been born. Following the first position uh, forced Einstein to spend a lot of time on fruitless attempts to build a unified theory on this path. So yeah, this was like his big struggle with maintaining what is it covariance um, with everything. And so like his unified theory was supposed to establish covariance with everything, but his fundamental framework was completely off, so he could never do it. And that was his great struggle or whatever, and that's why he couldn't do it. It is clear from these examples the arbitrariness of the application of the principle of simplicity can have far-reaching consequences. On the other hand, considering matter and phenomenon in their entirety of their properties is impossible, since the number of properties of any material is is infinitely large. Hence, the methodological importance of the raised problem becomes obvious. In order to determine how the essential aspects of an object and phenomenon can be distinguished, it is useful to consider the issue from the historical perspective. In philosophical literature, it is considered that the requirements for analyzing the essence of natural phenomenon were uh, were first put forward by Thales of Miletus. If before him nature was considered as something unified, Thales Thales saw that the unity in the presence of many differences having a common primary basis, and thus pointed out the complexity of nature and the principle of direction of the analysis of the phenomenon on the way of finding some common primary basis. He considered such a primordial basis to be a wet nature, in, in modern terms, hydromechanics. Oh, you're straight, bro. We're just reading through this book, taking it chapter by chapter. Each chapter starts a new section. So this section is going over, can't even remember now. What was it? So ways to uncover the internal mechanisms of phenomenon. So he was starting by going over the history of phenomenon and mathematical abstractions to describe the phenomenon and what's called phenomenology, where you're just concerned with eloquently describing the phenomenon and not really concerned with with understanding the underlying mechanisms of it. So, for example, people are quite content with action at a distance and all that. And back in the day, there were people that were like, "Well, no, there can't be action at a distance. Everything has to be a mechanical interaction. There has to be some sort of pressure mediation. There has to be some sort of wave interaction. Something to carry the wave, et cetera, et cetera." So we're just looking at the history of that and the development or the development of science through the lens of materialism and idealism, and where they both diverge, and trying to find like a nice sweet spot in between them. So that's where we're at now. You didn't miss too much, but I do recommend going back and listening to it, in your free time or whatever, because the historicity of it all was quite interesting, although some of it was pretty dry. There's a lot of interesting tidbits in there, and I give some in-depth explanations on the interferometry side of things, because at the beginning he covers the experimental evidences put forward to show that there's an ether. When you reject when you reject a foundational medium and well-established forces, you end up having to invent a fundamental, which explains that's classic circular reasoning. Yeah, yeah. All right. So the so-called simplicity principle is often found to ignore the real physical picture of the world. The distant consequences of such an approach can lead to, and what it can lead to is shown by the example of Mach's statement rejecting the concept of quantity. Mach recognizes the notion of, oh, did I already read this? I think I read that already. Let's see. Yeah, okay, my bad. It should be noted that Einstein, okay, wait a minute. Okay, read that. Okay, read that. It should clean the arbitration. Yep, read that. Sorry, I forgot to look and see what page I was on before I scrolled back up to read the title. Okay, the properties were impossible since the number is infinitely large, blah, blah, blah. Okay, the philosophical, your boy. Yep, yep. Okay, yeah, hydromechanics right here. All right. Later, Empedocles, I'm just making that name up. So your boy, later, Empedocles proposed the four elements: earth, water, air, and fire as such a primordial basis, indicating that the very object of the phenomenon consists of combinations of these four elements. Empedical. You know what? I'm just gonna look up his name, boys. I can't keep reading it the wrong way. It's gonna drive me crazy. Oh, you're straight, bro. It took like 2 seconds to reread or to figure out where I was at. So let's see how to pronounce. How to pronounce.
Empedocles.
Oh, Empedocles. All right, there we go. Empedocles. All right, so Empedocles thought it was much deeper than it is usually presented by historians. In fact, if we understand the concepts of elements used by Empedocles in what somewhat of a broader way, for example, earth, the solid and water states, liquid and air and gas and fire as energy, then we generally account for a reference to the three basic states of matter, solid, liquid, and gaseous, and the energy inherent in them. It should be noted that at the same time, that not giving each of these states any additional properties means that these elements introduced by man, I already forgot it.
Empedocles.
Empedocles were meant to be elementary in their basis, endowed with a single quantity. The development of alchemy in the Middle Ages raised question to another system of elements which all bodies are composed, the substance, in particular metals, sulfur, and some others, each of which was endowed with a limited group of qualities, each of which was endowed with a limited group of qualities were singled out. The idea of the genesis of the substances, expressed by R. Bacon in 1214 and 1292, is actually an attempt to synthesize the complex from the simple. Thus, even at this stage of development of the ideas about the structure of matter, complex substances are implied the consistent of and or to consist of simple ones processing the minimum qualities. The development of chemistry, led by the idea of the smallest particles of matter possessing all the chemical properties of, of a given substance, although the official term molecule was legitimized by the International Congress in Kruslow in 1860, and the term and its actual meaning had been known to Levioso. I feel like that guy's name is almost like Leviosa. Leviosaire. Let's see. I'll go with that. Leviosaire. Long before. So yeah, they had already had that going on. It is true that Leviosaire made the following admission: if by the name of the element we want to designate simple bodies and indivisible molecules of which the bodies are composed, it is very likely that we do not know them. It is likely that we do not. Nevertheless, the logic is preserved here, as well as complex object and body is measured to consist of simpler ones, molecules. Moreover, the substance that could not be decomposed. Uh, Lavoisier called simple, thus confirming the generality of the method. It's Lavoisier, dude. Exactly. That's hilarious. Dude, it's Lavoisier. You know what? If it is Lavoisier, that's awesome. Let's look it up.
Lavoisier.
Lavoisier. It's Lavoisier or whatever. Yeah, it's pretty close. So Lavoisier. So I wasn't even close. That sucks. All right. So anyway, your boy Lavoisier, aka Lavoisier, called simple, thus confirming the generality of the method. Further, the penetration to the depth of matter is associated with the name of J. Dalton in 1766 and 1844. In citation 23, Dalton notes, I have chosen the word atom to designate the primary particles, preferring it to the word particle, or molecule, or any other diminutive names, because this word to me seems considerably more expressive and includes the idea of indivisibility, which other designations do not, Dalton suggested. Yeah, so the idea of the atom as being indivisible, as cited by the guy that put forward the model of it, or one of the models, one of the iterations of it. Very nice, or the modern iteration of it, rather. Yeah, no, I got you, bro. I thought it would have been amazing though if it turned out to actually be Liviosar or whatever, and then we could have totally ran with that. Empedocles impede impediment? Yes, sir. All atoms of the same kind, differently simple or complex, must necessarily be regarded as identical with each other in form and appearance, and all other features. And altogether, later studies showed that this was not so. The idea of sameness of the atom, i.e., the metaphysical limitation of the properties, giving simplicity to the element brick of which more complex formations, molecules, substances, bodies are composed, was absolutely a necessary condition for the possibility of analyzing and synthesizing matter at this stage of development of natural science. The fact that the diversity of the atom, the presence of radiation emanating and the presence of radiation emanating from them, the transformation of atoms of the substance to into atoms of other substances established at the beginning of the 20th century showed that atoms are not the simplest and indivisiblest indivisiblest, that's definitely not a word, are not simplest and indivisible formations of matter. The planetary model of the atom proposed by Rutherford in 1911 made it possible to formulate the concept of elementary particles that make up the atom. Elementary particles were ascribed several limitation or limited properties, among one of which is the main ones is that their indivisibility. Oh, so the atom's not indivisible, it's the elementary particle that makes it up that's indivisible. All right, they just did a little indivisibility switch. I like it. Thus, at this stage of development, atoms were recognized as complex entities, and all their diversities was explained by the combination of elementary particles. It wasn't until we penetrated deeper into the atomic nucleus where we discovered that the atoms themselves, elementary particles, are not elementary at all. Oh no! And summarizing the above, we note a common methodological approach to analyze the structure of matter at all stages of development in natural science. This methodology consists of the following: the accumulation of facts about the diversity of properties, forms, and the motions of matter raises the questions about the complexities of already studied forms of matter and about the presence of common forms and properties of matter at the level deeper than already mastered levels. These forms and properties, A, a sim- are simple in the sense that there are a small number of essential qualities attributed to them, and B, arise from the forms of peculiarities of the motions of matter and the previous older levels of organizations of matter, and C, are only a part of the properties of matter at considered the younger level of the organization of matter, which at the initial stage of mastering this level of the organization of matter has temporarily been neglected, at least until the accumulation of necessary data. Oh, I'm sorry. That initial level has to be initially neglected until sufficient data has been collected. Gotcha. Okay. All right. In the future, the accumulation of new data material formations of this level will again appear to be complex, and again, it will be necessary to introduce ideas about an even deeper level of organization of matter, the bricks of which upon will be built, or the bricks of bin will be temporarily considered simple. It should be noted that the properties of matter found at new levels of organization can only be essential for only or for only such of them as explain the variety of the forms and properties of matter at the previous level of organizations are distinguished. Thus, in contrast, the subjective notion of the simplicity of the phenomenon described above when studying the properties of matter at different levels of organization, we deal with the dialectical notion of simplicity. Yo, what up, Jim? Shout out to my boy. What up, G? Yeah, dude. Not only did they say it was the smallest and couldn't be divided, but then they were like, no, no, it's actually smaller than that. And then there's like other little tiny things. And these are the real ones that are actually indivisible and all that. It's like, what? It's like, but I have this math equation to back it up. And everyone's like, all right, well, we'll hear you out. All right, let's see here. Where are we at? Methodological simplicity. The the found general methodological principles should be applied at the present time, since enough data has been accumulated on the complexity of elementary particles and matter of their diversity, as well as their mutual transformations, indicating the presence of a common building material. Absolutely, brother. It follows that it follows from the above that it is necessary to analyze the interactions behavior of elementary particles of matter to single out characteristics common to all the interactions on the basis of the analysis to give the properties of elementary to a new smaller formations of matter, which are the building materials for elementary particles of matter, to deduce from their properties various forms of motion or various forms of their motion, to build on the basis of these forms and these interactions of senior forms starting from elementary particles and from the universe as a whole, as well as to predict the. You know what's crazy, man? Have you guys ever seen a mandible set? Like, I feel like as you break down the analyzation of each one of these of every physical phenomenon further and further to find the mechanical interaction of it, it's almost like it's a like a mandible set. It just keeps breaking down, and then it's like, hold on one second, let me pull this up. Mandelbrot set. Zoom. Check this out. Try not to get hypnotized or whatever. It's like, oh, yo, we're having thoughts and building a framework for philosophy and science and natural science and physics and all that. It's like, oh, we're discovering new stuff. Oh, we don't know what we're doing now. Oh, we found some contradictions. It's all complicated again, and then and then it gets, it just keeps repeating, and then it's back to normal. They figured it out. They figured it out. Everything's good. Oh wait, what's this? It's getting crazy again. It's just like, I feel like that's the cycle that's being described here in the book. It's like, this is the atom, guys. It can't go any further than this. And it's like, wait, what's that? Hold on. Do you see that? Oh shoot, we're going further. It actually goes further. It keeps going, turns out. And then like that never-ending cascade of whatever, is the mechanisms for motions of all levels, right? It follows from the above that it is necessary to analyze the interactions of elementary particles of matter to single out characteristics common to all those interactions on the basis of the analysis to give the properties to. Oh, I already read that one. My bad. The methodological principle outlined above has been repeatedly used by various researchers in relation to private problems of the kinetic theory of matter. For example, by Boltzmann in citation 14, and also by A.K. Tamirezev in citation 24, and quite successfully. Conclusions. 1. The main goal of natural science should be to reveal the nature of phenomenon, i.e., to reveal the internal mechanism of the phenomenon, cause and effect relationships between the material entities involved in them, and on the basis of their generalization to find general laws of the structure of nature. The existence of internal mechanisms of the phenomenon presuppose the existence of the causal relation, i.e., determinism. 2. Recognition of the fact that causality raises the question about the nature of elementary interactions within phenomenon. These interactions between elements can occur only through direct contact of a common point of space, thereby fundamentally rejecting the principle of long-range action at a distance. Assuming the interaction of the bodies through the void is asserting the principle of close action at any level of organization of matter. 3. Every object and every phenomenon has countless sides of qualities. So every concrete description, i.e., model or mathematical formula, verbal and graphical description, etc., is an approximation. This means that the representation of objects and phenomenon must be continuously refined by improving physical models and their mathematical descriptions. It also means that the improvement of the fundamental dependencies of physics, reflecting on the part of general regularities of nature, should be one of the most important tasks of theoretical physics. 4. Any mathematical, logical, functional, quantitative description should be preceded by a qualitative description, constructs of models and objects of phenomenon. Models should reflect the qualitative sides of objects and phenomenon, explain them from the qualitative side, i.e., reduce them to a set of parts, each of which can be considered already understandable in its basic properties and their interaction. Hence, the fundamental importance of applying analogies to known objects and phenomenon and justifying the legitimacy of applying certain analogies in specific cases. 5. When constructing general physical theories, the fundamental importance of the definition of universal physical invariants, categories that do not change their properties under any transformation, and the interactions of physical bodies, general and physical invariants should not be postulated, but defined on the basis of generalized analysis of all known physical interactions and phenomenon. The criterion of the selection of universal physical invariants corresponds to the fact of presence of these categories in all material entities and the phenomenon in nature without exception. So no saying space-time is bending and that's causing a contraction of the coordinate system to make it all fit. We're not allowed to do that. All right. 6. Categories that do not satisfy the principles of universality cannot be universal physical invariants. Thus, such categories as the fourth dimensional interval or the speed of light proclaimed by Einstein's theory of relativity as universal invariance is inappropriate. It is even more inappropriate to extend electromagnetic concepts, i.e., the speed of light, to gravitational phenomenon, and the general theory of relativity, claiming claiming to be the theory of gravitation, since gravitational phenomenon have no relation to electromagnetism. That's so true. And you know what? Your boy Stephen Crothers pointed that out when he did his analysis of LIGO. He did a mathematical analysis of what they used to derive the electromagnetic, or I'm sorry, the gravitational wave ripples, from the so-called black holes, and he found that they arbitrarily make the speed of the gravitational wave fit the electromagnetic wave propagation arbitrarily. They could have made it any speed, but they chose it to make it the speed of light to make it seem, more in line and consistent with the theories of gravitation, and etc. Because that's what it was really all about, too, right? Like reifying that. And yeah, he absolutely, yeah, I'll pull it up actually so we could take a quick look at it. Stephen Crothers, what's his, yeah, Rex. Let's see, where was the LIGO? Yeah, he dunked on it. A critical analysis of LIGO. Yeah. So let's see. Okay, yeah. So Appendix A represents the mathematical means of linearization of Einstein's field equations, revealing the arbitrary nature of the speed of his gravitational waves. So what he shows here, and then all the way down here at Appendix A, down here he goes into detail on this, and maths it out or whatever, contracts it all out, and he shows exactly that. So let's see what his conclusion here was at the end of this, which by equation A10 describes the wave propagating at the speed in a vacuum. However, the crucial point of the foregoing mathematical development is that Einstein's gravitational waves do not have a unique speed of propagation. The speed of waves is coordinate dependent as as a condition of equation A6 attest. It is the constraint of equation A6 that selects a set of coordinates to produce the propagation of C. A different set of coordinates yields a different speed of propagation. Oh, okay. So yeah, if he transforms it into a coordinate system that describes a different medium than that of a vacuum, um, it still works out proportionally. Like it doesn't have any physical meaning the way that they did this. Okay, so that makes sense. It's cool to come back after learning about covariance and like have more being able to understand this a lot better. That makes yeah, that's awesome. That's hilarious. Because I don't, it's like all this, like I don't, like who knows what all this is, right? This is all gibbery jabber. But when he gets into the coordinate system transformations and how he's saying that it doesn't have a unique speed constraint, so when you transform it into a coordinate system, maybe something in the coordinate system that describes, a medium of water or whatever, like the propagation speed would be facilitated by that. So he's saying that this prediction and making it equivalent to the speed of light is just they just do it to make it seem like it's on the up and up here. So let's see. Einstein deliberately chose a set of coordinates that yields the desired speed of propagation at light in a vacuum, i.e., almost 300 million meters a second or per second squared, in order to justify the presupposition that the propagation is at the speed of c. There is no a priori reason why this particular set of coordinates is better than any others. The sole purpose for this choice is to obtain the desired presupposed result. Quote, all coordinate systems differ from Galilean coordinate systems by small quantities to the first order. The potential G sub UV, which is Einstein's tensor, let's see, pertains not only to the gravitational influence, which has the objective reality, but also to the coordinate system, which we select arbitrarily. We can propagate coordinate changes with the speed of thought, and thus may be mixed up and and these may be mixed up at will with the most dilatory propagation discussed, or with much more dilatory propagation discussed above. There does not seem to be any way of distinguishing a physical and conventional part in the changes of GUV. This statement, the statement that in relativity theory gravitational waves propagate at the speed of light, has, I believe, been based entirely upon foregoing investigation, but it will be seen as though that it is not only true in a very conventional sense if the coordinates are chosen to satisfy a certain condition which has which no longer or which has no very clear geometrical importance. The speed is that of light. If the coordinates are slightly different, then the speed altogether is different from that of light. The result stands or falls by the choice of the coordinate system. So as far can be judged, the coordinates here used were purposely used to introduce in order to obtain the simplification which the results from representing the propagation as occurring with the speed of light. The argument follows a vicious circle. Arthur Eddington. So that was the critique of Arthur Eddington, man, about coordinate systems and transformations of the speed of light. And this is a guy who later flip-flopped, became a complete Einstein, facilitator and propagandist. So, yeah, very cool, man. So they just chose a coordinate system to reflect what they needed to, and now gravitational waves exist and they're confirmed by LIGO. Very cool. Shout out to Stephen Crothers. Absolute G. All right. So that was in regards to section 6. Let's see. 7. The carried out generalized analysis shows that matter, space, and time, which represents the motion of matter, are categorized presents everywhere. Therefore, these categories everywhere act as a universal physical invariance, primary concepts, which relation to, or which, in relation to which all other physical laws should be considered. 7. Or nope, that's it. That's all 7. That's all of them. Oh, no, there's more. As universal physical invariants, matter, space, and time, and their aggregate motion have the properties of the presence in all structures and the phenomenon primordiality, preservation under any transformation, infinite divisibility, additivity, linearity, and unlimitedness. Yeah, so that was really important for that. So earlier in a couple chapters back, I forget how long ago it was, but he established that. So in terms of postulates, so like Einstein, just a postulate is just he refers to it as this guy, not Einstein. Atsukovsky refers to a postulate as an ingenious conjecture, which is hilarious, I think. So it doesn't have any meaning to it, right? It's not like based on anything. It's just like Einstein saw the relationship between a moving magnet over a stationary conductor and a moving conductor over a stationary magnet. And thus he postulated that all reference frames are equally valid because no matter the motion, there's an effect. And from that, he also, from the second part, he concluded that the speed of light is independent of the source and observer in all reference frames in a vacuum, thus removing the ether. And also, he also removed the ether in the first postulate with the reference frame thing too, because that's also a mathematical construct to have a preferred reference frame for that. But anyway, so these two, Stephen Crothers, Stephen Crowthers, I think. Yeah, Crothers. I'm like 50 miles south of LIGO and at Hanford. There is no way they could be detecting gravity wave from space, even if space were possible. That there's nothing between us and that phenomenon. Shake my head. Yeah, dude, they're literally saying that there's a ripple in the coordinate system that's been going on for 11 billion years when these two rotating black holes coalesced into each other. And yeah, if you want the link, I'll link you this stuff. My bad. I should have linked it to. Uh, so right here's his work. And then if you control F and go down to LIGO, a critical analysis, this is the paper I was referencing. This is a great paper to dip your toes in for his work. He writes very technical and assumes that like everyone knows all the jargon that he's uh, putting forward. But like, once you overcome that, it's like the dude's spitting straight facts because he has a really interesting critique about the mathematic structure of relativity theory where it violates covariance. But anyway, let's see here. This means, in particular, Euclidean real physical space, uniformity and unidirectional of time, eternity and indestructibility of matter, space and time and motion are preservations of the universe in the average form of absence of the beginning and in the end. The universe as a whole is stationary with stationary and dynamic. There is a continuous series of processes in it which all are without exception connected with the movement of matter in space and thus are mechanical processes. So what he was talking about though was the postulates, right? So to backtrack on that, sorry, I kind of blacked out for a second. So to backtrack on the postulates thing, so Einstein built this framework, well, co-opted Lorentz's ether framework really, and used his postulates to assert that there's no ether. And this guy's saying, if you're going to have things that are or that are invariant under transformation, like what laws are you going to decide to make invariant? Can it be something like the speed of light and all that stuff where it's been experimentally shown that it varies, so that can't be an invariant, right? So what he pointed out was that there's space, there's time, and there's what was the other one? And matter. So these things are physical invariants because these are all things that objectively exist, right? And then there's the aggregate of them. So like all of these things together produce motion. And so that's what he was putting forward in terms of the invariance of the framework. And I think that that's really important for the fundamental basis to start off with, like something that's actually that you can actually objectively analyze and scrutinize and not be like, well, here's 50 experiments that show that there's a variance in the speed of light that corresponds to a direct translation of motion from the sky, so much so that we're measuring the motion of the sun moving above us. So all right, this means in particular. Okay, I read that. Okay, 8. It follows from properties of universal physical invariance for for macro and microcosms that there are no preferred scales for motion, matter, space, and time, and therefore at all levels of organization of matter and macro. The physical laws apply in the microcosm, and there is no special physical laws in the microcosm. This allows us to analogize. This allows us to use analogies of the microcosm when analyzing phenomenon and developing models of the material structure. 9. The main direction of the development of natural science has always been the development in depth of the hierarchical organization of matter. The next stage of development was remarked by the introduction of stages about the material entities smaller in mass and size. The material formations were temporarily attributed to the simplest in terms of form and form interaction. 10. The structures of organizations of matter extend infinitely deep and upward through hierarchical levels. The total number of levels is infinite. The total amount of matter in space and time and motion in the universe is infinite. However, each specific process encompasses a limited amount of matter, space, and time and motion. The latter, in the particular, means the limit of propagation in space and time in any fields of any fields in interactions. 11. All provisions and methodology of ether dynamics fully corresponds to the provisions of dialectical materialism. Chapter 4. The structure of the ether. All right, let's see where we're at here, where we're at on time. All right, we got 1 hour and about 20 minutes. Okay, I think this is probably a good spot to wrap it up at. So we'll pick up here tomorrow on chapter 4. All right, guys, you have a good night.